Okay, it's my pleasure to welcome to this plenary session where we are going to talk about, well, two of the most outstanding topics that are wandering around the brain of the people doing networking during the last period. And I have only some housekeeping announcement to tell you first, which I will remind you at the end of the session. And first of all, the conference organization reminds me that you have an evaluation form in your bags. So you are kindly asked to fill it up and not to bring it back at home, but to leave it here when you leave. There will be people, well, one of them will be Bert, chasing you around, asking for you to leave the evaluation form. That's the way we try to improve next year conference as well. So please do. And the second announcement is please check that there are two sessions also after this session which are not correctly announced in the program, session 2C and session 2D. Both of them are on the 17th floor, so if you are superstitious, please come. And these two sessions will happen over there, and the 2C session is the one where we try to decide which kind of new projects it's worth to follow for the next year. So we are dealing with a lot of new stuff. It's not presentation stuff, it's an open discussion. So it's very useful that you come there and you say what's your opinion about that. And for the presenter, there is also the occasion for them to sell their ideas and to find partners for projects. Remember that 2D exists, even if it is not written correctly on the program. Also remember that we end at 12:30. Not at 12, as it is written down in the program. Otherwise, the second session will be only 1 hour long. And don't worry about starving, because lunch will be served anyhow to you. And if you're really starving, you can start at 12 and leave the session before. So, end of housekeeping. And what I would like to do now is just to introduce our first speaker this morning, and it's a very easy task. Maybe I just need the name, Jan Forsters. Well, for those of you who still don't know who Jan is, think of grids. Think of a couple of very famous books that he wrote some years ago, telling the people, why don't we use this idle CPU time, idle storage, idle stuff which is along the network, and we use the network as the computer, and we organize everything like that. Well, Jan was one of the members of the Argonne National Laboratory. We started to think about this idea, and then he realized and produced the first version of the software, which now became the Globus Toolkit, which is the basis for all the grid applications which are run around the world. And he is also professor at Chicago University now. And I think he's one of the few scientists who has got a number of medals also in his curriculum. So, yeah, please, floor is to you.
And increasingly, as we all know, and I think the reason why we're all here is these people work not in isolation, but within increasingly complex and distributed teams, communities, what we sometimes call virtual organizations. These groups tend to be heterogeneous in their makeup because, of course, there isn't much use in talking or collaborating with other people who are identical to you in terms of the resources they provide or the expertise that they have. That doesn't add much to your overall strength. They tend to be geographically distributed, spanning multiple physical organizations, and often, of course, organizations with different political or economic or other motivations and structures, and they're also often very dynamic. So, in fact, I would say today the virtual organizations that we're working with tend to be relatively static and unwieldy, but we can see that we need to be forming organizations that are increasingly dynamic as we move forward. So here, for example, was a slide contributed by one of my physicist friends. Physicists are very good at drawing slides. You wouldn't, I guess they have a lot of time on their hands, right? So this shows, a vision of how the physicists collaborating in the Large Hadron Collider at CERN might structure themselves, actually, in some sense, structure themselves today and want to structure themselves increasingly in the future. Geographically, in fact, globally distributed, multiple thousands of people, and these thousands of people being formed into teams that have multiple overlapping and fluid memberships. So some of them may be engaged in production, computing in support of this particular physics experiment. Others may be looking at some futuristic research idea. Others may be looking at a different competing futuristic research idea. And these different groups need to be able to form, evolve, etc. Over time. So, of course, we've been trying to address the requirements of these groups for some time. Certainly not alone, but we identified some requirements some years ago and started to address them via various so-called grid technologies. But the basic requirement that we've been trying to address, and I think many of you here, for example, our Internet 2 colleagues are also trying to address from a different perspective, relates to how do you enable these distributed groups to form pool resources, whether information or computing or just interpersonal communication, and then apply those resources to these problem-solving activities. So if you talk about sharing as being a basic requirement, of course, thanks to the work of people in this community, we already have some very nice technology for sharing communications. We can communicate with each other. We're starting to see some technology that allows us to share data and knowledge, and we could point to, of course, the web and the work on the semantic web and shibboleth in the security area. What a lot of the grid community has been engaged in is trying to work out what is needed to share other parts of the infrastructure, services, computers, databases, hierarchical storage systems, programs, ultimately sensors, and so on. So, of course, as we address these issues, we have some technologies that we can draw upon, and so I put up the slide in some sense so that I won't get the question at the end, well, what about Corba, or what about other things, although you're, of course, welcome to ask that question nevertheless. So we have peer-to-peer technologies. There are several talks, in fact, at this conference about them, and they certainly provide some powerful mechanisms for certain classes of resource sharing. In their current instantiation, their scope and functionality is not sufficient to address the full range of sharing modalities that we want to address. We have the enterprise-level distributed computing resources used typically within an enterprise. And again, they are powerful but don't necessarily address the institutional issues that we're concerned with. And so on. Databases, web services, semantic web all have applicability and in fact are all going to form part of our overall solution but are not in themselves a solution. So what we're missing and what in fact the grid community, ourselves in the Globus project and others in the Global Grid Forum have been working to address for some time now is mechanisms that will allow us to share and integrate a range of resources, addressing issues of resource discovery, provisioning, access, remote access, controlled remote access, controlled, secure, reliable remote access to computation and data, security, policy, dealing with the inevitable faults, and providing overall distributed system management functions. So that's sort of the end of my introduction to trying to set the scene for grid computing. So what we're interested in doing is providing infrastructure elements that will allow us to establish, manage, and evolve these distributed virtual organizations, and then support various forms of workflow and problem solving within these organizations, allowing people to discover, integrate, access, and manage distributed collections of services, resources, etc. So what I want to do now is talk a bit about where we are in terms of developing technologies to address these concerns. So of course, this slide, if I had more room, would go much further to the left, because we're building on all of the work that's gone on in the internet community since at least the late 60s. But I'd say the work that we're focusing on here really started in the early 90s with the emergence of gigabit testbeds, both in the US and Europe, and various experiments where people tried to identify what might be possible when you had high-speed networks connecting various interesting resources. And various custom solutions were put in place, not necessarily secure or broadly applicable, but allowing people to explore what might be possible. Later in the 90s, of course, there were a variety of experiments ongoing and various technologies being put in place, but one I think that proved particularly useful and influential was the work on the Globus toolkit that my group and others put together. And here, building on internet standards, there was an effort to define some fairly basic but useful mechanisms that address some pain points that occur when you try and create distributed applications. So technologies for single sign-on, authentication, authorization, resource discovery, resource access, access to computing, access to data, and so on and so forth. This, of course, was in a sense, a de facto standard, not a real standard, and thus, of course, has limitations in terms of its scalability, scalability in terms of adoption. Over the last couple of years now, we've seen an effort that builds on the work in the Globus toolkit and a number of other related activities, and attempts to define real standards in the sense of technical specifications that are long and boring and precise, and can actually be implemented by multiple groups. And this so-called Open Grid Services architecture has, in the last few months, produced some formal standards documents which are now being, I guess the official status is they're still draft specifications. I can't remember the exact, they're in a public comment period, but at least they're finalized, and there are multiple implementations underway. The Globus Toolkit version 3 provides one. There are at least a couple of others that I'm aware of, one from the Unicore project and one at the University of Virginia in a .NET environment. And as I'll explain, what the Open Grid Services architecture does is, building heavily on web services technologies, it attempts to address those same pain points that I mentioned earlier, plus a number of others, to define an overarching middleware architecture for the sorts of applications that I talked about earlier. Of course, we have to. There's no pretense that the OGSA definition solves all of the world's problems, but it does seem to be an interesting framework on which to place such problem solutions. But there are many people trying to extend the scope of such solutions. Okay, so now let me move on and talk about OGSA in a little bit more detail. Some key points here. First of all, service-oriented architecture. So I'm sure you're familiar with what that term means. As in web services, we adopt a uniform, and as in Corba for that matter, and a number of other technologies, we adopt an approach in which all entities are represented as services, network accessible services, with their capabilities defined by a well-defined interface definition language, in our case the web services description language. There's a lot of focus put on leveraging industry web services standards, and then in terms of the added value that's been provided, a lot of focus on functionality relating to distributed service and distributed system management. In fact, if you're a web services person, you might say that OGSA in particular adds a component model and distributed service management model to web services. If you're a grid or distributed application person, you'd say we're adopting web services interface definition language technology for the functionality that we've had previously in more primitive forms within the Globus toolkit and elsewhere. So I'm sure you're familiar with web services, so let me put up my one slide. Basically little to do with the web, a lot to do with services, a now broadly adopted distributed computing technology with also some nice technical features, allows us to represent using XML syntax and technologies a distributed system framework in which everything in our network is thought of as a server process with a interface defined by the web services description language. And of course the nice feature about it is that a WSDL document can completely define a service and how to access it. So OGSA then adopts the WSDL technology coming out of web services, which can be used to define interfaces to static web services, the traditional stock quote service or the weather service or the database service, but then adds to that framework a set of standard interfaces and behaviors defined in WSDL terms that address many of the issues that arise when you try and build large-scale distributed services and distributed applications of the sort that arise, for example, in science, but also in industry. So as we'll see, it defines the interfaces and behaviors that speak to issues of how services are created, how their lifetime is managed, how you introspect on them to determine their current and potentially future characteristics, how you deliver messages between them for purposes of notification and things like that. This core defines what we call the grid service. So a grid service is a web service plus some extra stuff. The specification that defines that is called the Open Grid Services infrastructure. And then on top of this, there's and in some sense beneath it as well, as I'll explain in a minute, there's a whole set of activities ongoing trying to define standard specifications for things like resource management, data access, manageability, security, diagnostics, and so on and so forth. And of course, we're already starting to see a lot of more application-specific services that build on top of those functions. So this slide is my attempt to define the core Open Grid Services infrastructure specification in a single slide. So I first of all imagine that we have basically a standard web service, which in this case is perhaps encapsulates a database. So it has a single interface, the data access interface that maybe has some methods defined for querying a database and maybe updating the database. And of course, as in any service-oriented system, that interface can then be implemented in different ways in different hosting environments. If we could replace this data access service with a computer or some computational service or a router, I guess, if you had the appropriate interfaces defined. It's any network accessible entity. So if you're using web services, all you get is this data access service. All you get is the machinery that lets you define this interface and then invoke operations on that interface. And what OGSI is going to then do is define a set of additional functionality. So first of all, we'll define some global naming capabilities that allow us to define so-called grid service handles that can be resolved to grid service references, where grid service references are actual WSDL documents that can be used to reference the service instance. So I won't go into that in more detail, but we could cover it later if you're interested. The next thing that we do is introduce support for introspection. So this is sort of obvious, I'm sure, to all of you, but in any sort of large-scale distributed system, the ability to manage things depends on your ability to determine their properties. And in web services, there's no automated or standard way of discovering or indeed defining the properties of services or other entities. In the Globus Toolkit, we've long had some basic mechanisms for publishing and then subsequently discovering properties of certain classes of entities. This was our so-called monitoring and discovery service, which leveraged LDAP technology. In OGSI, we generalize those ideas so they can be applied to any service, and of course we restructure them and reinvent them in a web services framework. So in OGSI, any service, in other words, any entity in our network, can have a set of so-called service data elements associated with it. So these are typed, named XML elements that are defined in terms of their structure and syntax when you define a service interface, and could then be accessed via standard methods associated with a so-called grid service interface or port type that is supported by any standard compliant grid service. So in the case of a database, I might define some service data elements associated with the database that perhaps specify the type of database, its current load, maybe the policy that governs access. In addition, there would be some standard grid service associated port types, service data elements that might define, or they do define, I should say, the grid service handle, the interfaces that the service supports, and so on. In the standard grid service interface, then the first thing it gives us thus is introspection. The second thing that we define is lifetime management. So in the sorts of distributed applications that we want to be able to support, and I suspect the ones that you want to be able to support, the entities that people want to be able to access, create, discover, employ are not necessarily persistent. They don't live forever. They may be created as a result of some activity. They may have a finite lifetime, and they may eventually disappear. And we want to be able to ideally manage and reason about and discover these various lifetime properties. So OGSI defines lifetime management functions that allow us, for example, to create an entity with a certain lifetime, extend that lifetime, so soft state ideas are being employed, and then also explicitly destroy something if we want. So just to use an example, maybe I'm setting up some sort of distributed video conferencing session. Maybe I would instantiate service instances that would represent perhaps different participants in the session, that would manage group membership, that would perform various translation functions from one format to another. I would like for all of those various stateful services that I create to be destroyed when my video conferencing session shuts down, and I can do that by using these lifetime management functions. Then finally, we define a few other standard interfaces that I won't talk about that address things like service creation, notification, management of collections of services, and so forth. Okay, so that's OGSI. That's the core of OGSA. It's what is defined by this document. I think the reference number I have on here is not the final version. The final version is dated a little bit later and is maybe -29 or something. But if you go to the OGSI or the Global Grid Forum website, you can find the version of this document that is currently in the public comment phase of the standardization process. So here's an example just to show what this machinery allows us to do. So of course, I can build all sorts of interesting applications, but one particularly nice thing that it becomes possible to do, in fact quite easy to do, is to start to build network entities that are easily managed and monitored using standard mechanisms. So for example, in a variety of application domains, the ability to move data around in controlled fashions with resource management governing what gets managed where, and perhaps also network monitoring having some impact as to what gets moved where, is very important. And so we might want to define a reliable file transfer service. In fact, quite a few groups are doing this at the moment, that would provide a nice WSDL interface that would support operations, such as move this file from here to here, inquiries about whether a particular movement is finished or when it would be finished, perhaps also policy management operations that would prioritize one sort of transfer over another. And so in order to do that in an OGSI context, we have to define that interface and implement the logic to effect those transfers. But then once we've done that, we get a whole set of other things for free. So first of all, we can define, does this work? We can define a set of service data elements that represent, for example, perhaps pending transfers, performance of previous transfers, policy that governs who's allowed to do transfers, and various fault conditions that might occur. Once I've done that, then any external entity, for example, a fault manager or a performance monitor or a troubleshooting service, can simply subscribe to or query those service data elements to keep track of what's going on in this entity. Other clients can use standard interfaces such as the grid service interface, the notification source interface, policy management interfaces to query or update policy, to manage the lifetime of this thing, and so on and so forth. So a lot of sophisticated behaviors can be constructed once I decide to express this basic service as a grid service. So where are we in terms of larger OGSA, the larger process of defining an open grid services architecture? So this slide attempts to show the overall picture of what is being defined. So building on web services and other related technologies, we've defined this open grid services infrastructure. That process is complete. And there's now a whole bunch of activities ongoing, some advanced, some not so advanced, defining various other standard interfaces and behaviors for different distributed system management functions. Building on this OGSI context. So some of the key areas being addressed are data access and integration. This is an activity that's particularly based within the UK e-science program, although there's a lot of involvement of others, and that's defining standard interfaces and behaviors for accessing and managing and querying and federating distributed databases. Security, I'll show another slide about that, but there the interest is in understanding how the web services security framework can be applied, extended, modified to support various grid distributed application scenarios. Service level agreement negotiation, taking what is currently defined within the Globus toolkit as a remote service, remote computation invocation function, and significantly generalizing it, in fact changing it quite dramatically to support general service level agreement negotiation. So there will be a protocol that allows me to negotiate with another entity a general service level agreement which may cover the type of service to be provided, the time when it's provided, the duration for which it will be provided, and then having established such a service level agreement, I will then be able to bind it to various computation or data transfer or other activities, and then subsequently then monitor its execution. And then finally, there's a lot of interest in manageability. And I'll say more about that in a few slides. Those areas are well along, and there's others that are just starting, for example, relating to policy and data replication and a number of others. So here's a slide which expresses, I guess, some current perspectives of the Global Grid Forum group working in the security area. What's happening basically is a couple of things. One is working out how to take the current grid security infrastructure within the Globus toolkit, which is the public key-based technology for federating across institutions, working out how to take that and host it or apply it within the web services security framework. And that the first specifications for that purpose are in place, and the Globus toolkit version 3, for example, implements them. At the same time, there's a lot of effort ongoing trying to understand how to move beyond there and do address more flexible issues of authorization and authentication and policy management, as well as some initial thoughts relating to things like auditing and attribute management and so forth. One area which I think we'll see some very interesting interactions in the next year or two relates to how this work might join forces with the Shibboleth work and the work within the Liberty Alliance in order to address issues of particularly attribute management in distributed systems. So we already have definitions for WS secure conversation, which builds on what's going on in WS security and also what's going on in GSI, and that's implemented within the Globus toolkit version 3. There's work started on defining some standard credential management interfaces that would allow us to bring together various approaches to credential management, such as MyProxy and the Kenti and the Community Authorization Service and a number of other related technologies, some of which you may have heard of and others you probably haven't, all of which represent somewhat different takes on the questions of how a virtual organization manages membership and credentials and related activities. So the neat thing is that we're seeing standard approaches to these problems arise because of this adoption of a uniform OGSA architecture. Let me say a few words about manageability. So this is a fairly high priority effort within the Global Grid Forum. I'd say particularly interesting to some of the industrial participants. And the interest is in defining building on this OGSI base, some standard schema for representing capabilities and standard interfaces that would define then something called a manageable resource. So a manageable resource is a resource modeled as a grid service, so therefore having these service data elements and other capabilities. That is then further extended to define some standard schema for representing resource properties and standard interfaces for things like lifetime, more advanced lifetime management. And there's pretty heavy emphasis on leveraging SIM schema coming out of DMTF as a basis for this work. So just a few words on how this is working in the draft proposals that have been put together. So a resource is named by one of these grid service handles that I mentioned earlier. The state of a resource is defined by service data elements, which of course then can be accessed by the standard service data element access operations. Lifetime management is based on OGSI lifetime management with some extensions. We can use the OGSI service group construct to group resources, and of course we use WSDL as the interface definition language. And so, yeah, here's a little picture showing some of the initial interfaces that are being defined. So there's this notion of a base manageable resource interface that's constructed from the grid service interface plus others concerned with location, relationship management, and life cycle modeling. I don't think this adds, this slide doesn't add too much, but I just really threw these slides up to give you an idea of some of the areas in which work is ongoing, and I hopefully also the relevance of these areas, the work in these areas to your interest. So, initially, the focus in this group, I would say, is on computational resources, and that's just, I think, a product of the people who are involved. But over time, there's no reason, for example, why this should not be extended to network resources if there's interest from people, for example, people in this community. I think I'll skip this one. Okay, so I'm getting near to the end of my presentation. I wanted to throw up just a few more slides. So this first one is maybe not applicable to you, but is certainly, these are misconceptions that we sometimes see among people in the grid community concerning OGSA and what it means for how they develop applications. So one is that, first of all, because OGSA is based on web services, and web services is Java and J2EE, that means that OGSA requires that you now implement everything that you ever want to write in Java rather than some other language. And that, of course, isn't true. The web services description language is language independent. It can have bindings from many different languages. We, in particular, ourselves in the Globus project are delivering C client bindings as well as Java client bindings. Others are developing Python client bindings, and there are people working on .NET and J2EE and C server-side implementations. And so there's no binding to any particular language. All we're getting out of OGSA is a nice, apart from the various, often quite sophisticated behaviors, is the web services description language as an interface definition language. Another concern that application people sometimes express is that all programs must be restructured to be services that are invoked by operations defined by web services description language interface definitions. And here again, the answer is that's not really the case. Certainly, if you want to exploit some of the nice features of the web services, grid services model, then it's advantageous to express your applications in terms of a service model. But there's no real reason that there's no reason why you have to do that. And so a few very system-specific acronyms here, just pointing out that, for example, if you're used to using the Globus Toolkit GRAM interface, which is our remote computational resource management protocol, then you can still do exactly the same thing in a GT3, in an OGSA framework. And then finally, people always like to think that all their problems are being solved for them. So some people believe that web services or OGSA is a silver bullet that solves all of their distributed and collaborative computing problems. I remember someone telling me a couple of years ago that they didn't need a scheduler anymore because they had XML, which I guess they viewed as being some universal scheduling solution rather than a syntax. So again, OGSA is not a silver bullet for any particular distributed or collaborative computing problems, but it does provide a nice architecture, first of all, and it does, in terms of its current instantiation, define some nice behaviors and associated interfaces that address a number of pain points that arise when you're trying to build large-scale distributed collaborative applications. Okay, so how are we doing for time? Just 2 minutes, okay, good. So let me conclude with a couple more slides. One, just point out that in about a month from now we'll release, we already have an alpha out, we'll have a full release of Globus Toolkit version 3, which provides an open source implementation of many of these OGSA behaviors. Contributions from quite a few people. The number of contributors to this OGSA-based code base is growing. And then second point, mention that in order to encourage community contributions to this OGSA code base, we've established something called the Grid Technology Repository with URL on this slide. So I encourage you to have a look at this and also consider contributing code, documentation, interface definitions, etc., in order to more rapidly grow the OGSA compliant technology base. And then finally, just a couple of words which may be particularly relevant to your interests. So an area in which I think we're starting to make progress in terms of conversions, but are not completely there yet, relates to what sort of infrastructure is needed to support the sorts of application communities that I talk to and that I'm sure that you talk to as well. So we're quite used to the notion that we need to have broadly deployed network infrastructure, name servers and routers and all that sort of stuff. Increasingly, we're seeing, I think, a recognition that we need other sorts of infrastructure to support these sorts of collaborative applications that OGSA, for example, was designed to support. But that infrastructure is still mostly being operated by the scientists or researchers or academics themselves, rather than by people in the networking services hearts of their institutions. And over time, that clearly has to change, and that's obviously going to require a lot of conversations and probably adaptation of requirements and perspectives from both sides. But we are seeing various projects underway that are creating such infrastructure. So things like the TerraGrid in the US and the UK eScience Grid, and the EU Data Grid, the NEES Grid for earthquake engineering. Other things like this are starting at least to get some experience in what it means to build production infrastructures that deploy services such as those that I've been discussing. Okay, so that's all I had to say. So in summary, I hope I've given you at least a very brief idea of what OGSA is about, where we are in terms of its definition, and the scope of the activities that are underway to try and define more broadly this open grid services architecture. But we already have, and that's the key point, we already have defined and implemented a whole set of very interesting interfaces and behaviors that address many of the key distributed system management issues that arise and that need to be solved in order to build interesting distributed applications. And really, what's limiting progress now, I think, is the rate at which we can start applying that technology and defining higher level interfaces and behaviors in some standard fashion so that we can really start to exploit diverse activities in a productive fashion. Okay, so if you're interested in more information, there's a few URLs here for the OGSA working groups that have pointers to all key documents. And also, if you go to globus.org, you can find out about the current GT3 implementation. Thank you.
Right, so I think there was a couple of things going on which are perhaps not ideal. So people working at the application like middleware layer mostly assume that the network is like in those nice abstract network maps, the big cloud that's somewhat inaccessible and invisible, or at least inaccessible to the middleware. And then, of course, some people, another group, perhaps in some sense, sometimes the same people were saying, well, we'd like to be able to do things like perform bandwidth and quality of service reservations, but they don't really know how that might happen in practice. So I think we need to, and I think it's starting to happen, to establish a much more, much richer conversation between the networking community and we're working on middleware as to what functionality the networks can provide that will allow for richer, more reliable, more secure application level behaviors, and then what information, what demands applications might, more advanced applications might put on the network. So I had a conversation yesterday about IPv6, which is something that we're starting to think about a fair bit in the Globus toolkit, and what broad deployment of IPv6 mean for what we could do at the middleware layer. That's, again, I think a conversation that we're just starting. Thanks.
Thank you. It is not a coincidence that Ian and I are scheduled to talk in the same session. We work closely together. We are trying to take campus and lab enterprises and plumb them up towards the grid to provide sets of services. So Ian and I are on phone calls every Friday together for large numbers of hours. It's also the case that Ian speaks Queens English, and I'm from Queens, New York. So I want to talk a little bit about collaboration technologies and enterprise middleware. I want to explain what those terms are from our viewpoint. I will then talk a little bit about a day in the life of Jean Bleu, a biologist, as they spend their morning in research, their afternoon in teaching and management, and a night of personal life, a little bit of night of personal life. What might go wrong if we fail, and what might go wrong if we succeed. I think a bit of help. I'm not sure this is the right slide deck. I can probably hit the escape button myself, but I sent the slide deck in last night, and I'm not sure this was. Can someone help? Thanks. I know we had some slides I put in. I sent to Carol last night, and I hadn't. It's probably not that. No, I think we'll find it in a second. Or I can work off this. Right, this is the old deck. This is no. Oh, okay. We'll fake this. Is it possible to put my laptop up? Well, my laptop. Okay, we'll fake it. Okay. Well, let's see. It would be helpful to have the right slides. It's not necessary, but it's useful. Well, I haven't powered up my machine yet, but I can do that. Why don't we, I can start with this deck and then move over as my machine comes up. There is a line that we use at times like this that you know it's state of the art if it doesn't work.
They decided to froze not to show Windows logo.
Okay, this will work. Thank you. So, when we start to talk about collaborative technologies, we think about technologies like email, like desktop video, which is something that we've thought was going to be a killer application and has not yet happened, but it's something we're working on and we're quite close. I think almost every appliance we own in the next few years will want to do audio. That will raise an interesting question when somebody places a call to you and your PDA rings and your cell phone rings and your computer rings all at the same time, and you don't know which device to answer. So I think that we're headed for some interesting cases in that. In terms of the... yeah, as soon as it comes up. Thank you. In terms of, oh, this could be me. I have spent most of my life waiting for Bill Gates. And when he comes, it usually hangs. But we'll see what happens. Okay. Yeah. Hang on a second. I'm sorry. There we go. I knew it wasn't the right slide deck because it didn't have enough subtitles. As you all know, the quality of a talk, you must have a colon in your talk title, and then the more subtitles you have, the better the talk. So I added some last night. And I did want to mention, as Claudio did early on, that there's a misprint in the program that there is a session 2C on middleware and a session 2D on middleware, both simultaneous, and this is the discussion for 2D. So, I think, as we've heard, grids are an extremely important part of the world to come in terms of collaboration technologies for computation. You know about peer-to-peer. If you have not heard about a project called Smart Dust, it is a project out of Berkeley, California, with millions of sensors that are self-organizing. And the idea would be to use these in floods, in plagues, and in other kinds of technologies where you scatter these millions of sensors into the environment. They are self-organizing. They then begin to exchange information back to some kind of hub headquarters. As we move into the use of technology for support of humanitarian functions, this will be very important. There is important collaborative technologies in terms of scheduling and calendaring, as well as in terms of commerce. Whatever happened to B2B? Whatever happened to B2C? Well, those things will happen indeed. I think they will happen fairly soon now. Activities that are exploiting the web will allow those activities to finally move forward several years after the hype, which is good. So we talk about collaborative technologies and enterprise middleware. Let me define an enterprise. An enterprise is an organization that, as part of your belonging to it, helps you manage the information and access in an electronic world. I believe when we first started talking about middleware, we thought each user would carry around hundreds of electronic credentials and have lots of little pieces of information, and some website would say, "We need to know this about you," and you'd fumble through all of your electronic credentials trying to find the right one, and most people are not up to that. And so we're moving to a model where, in fact, your enterprise will help you release information and credentials about yourself. And typically, we will wind up with 3 or so enterprises in our life. Our university, our work, our corporations will be our primary enterprise that will help us release information. At home, we will probably contract with a service provider offering consumer services. This is what the world is betting on. And then you will probably have a personal one, a second service provider for extra privacy and security. In the U.S., we call that your Swiss bank account. I wonder what the Swiss call it. Christoph, what do you call Swiss bank accounts in Switzerland? So we know what enterprises are now. Enterprise middleware. These are some of the basic services that we want an enterprise to provide. Identity service, which is converting your real identity into electronic identities. Sometimes that electronic identity is connected directly to you. Sometimes it hides your identity for privacy considerations. One of the things that identity services needs to think about. Authentication is verifying that you are, in fact, that electronic identity. Most of the meaningful information about you will be carried in a directory. And then authorization is deciding what actions an identity is permitted to do. Those of us who are in middleware get together frequently and get lathered about how the world does not adequately differentiate authentication and authorization. These are critical distinctions, perhaps the most critical. because much of what you should be able to do is based upon your authorization, not your identity. And through that comes privacy, through that comes scaling. So over the last 2 or 3 years, we've been building the pieces of an enterprise middleware infrastructure. And today, many campuses, many national labs and other kinds of facilities are starting to have in place these type of pieces. The enterprise directory is very important. We once thought you were going to have a single directory. We now understand that most enterprises will have multiple directories, and so the meta directory that connects these together becomes even more important. You can see that in the Microsoft pricing. The directory is free, but the meta directory costs a lot of money. You can see that from other vendors as well. Some of those directories that may be out there in the campus, in your organization, are intended to support specific application communities, like grids, like video. I'll give you an example of why the video directory is different than the enterprise directory. The video directory will hold your location for video conferencing right now. That may change frequently in the course of a day. You will want to update that. We who operate the enterprise directory do not want you to touch it. So we will give you a video directory where you will be able to say, I'm here now, direct my video calls to this location, and you can do writes and reads to that directory easily. I won't go through all of the other pieces that are here, but I wanted to give you a sense of the richness of components that we are developing. We're almost done, because complexity is a grave concern in all of this. And so we have these pieces. Some of the rest of the picture is less clear. When we start to talk about authorization, and as Ian said, authorization is perhaps the holy grail for large numbers of services, then we know that there are some pieces out there, including the legacy business applications that fit into this, but we're not fully fleshed out what this piece is. We're working on it. We have passionate discussions every time we get together about how this will tie together. We're getting very close. So how does this all put together? How does the work that the grid is doing connect with our enterprises? This is our map of how that fits. And we, in our work of focusing mostly on core middleware, the identifiers, the directories, etc., but we want to plumb up to distributed computational environments such as the grid center. We want to plumb up to directly enable certain applications such as desktop video conferencing. We want to plumb up to advance virtual organizations that may not be computationally oriented. The talk yesterday about collaboration for culture. Catalogers, metadata workers need to have virtual organizations to support them. We're in that process. We worry about portals. We worry about learning management systems. And as Claudio suggested, we need to think down now, too, to the network layer middleware. We need to have the authentication and authorization that you get from your enterprise, be able to control your flows, maybe be able to control secure multicast. Now, multicast is very hard. Security is very hard. Secure multicast is almost impossible. But we have to do it if for no other reason than secure multicast goes by another name, pay-per-view. And pay-per-view is an important marketplace niche for us to develop a technology for. So we now have enterprises. We now have collaborative technologies. The last piece of this puzzle before Jean Bleu begins to work today is to federate these enterprises together. It's an inter-realm approach. You belong to an enterprise, but that enterprise wants to deal with other enterprises. It's very similar to the NRENs that many of us live with, the communities of universities that we live with. And so enterprises are realms, and they will mutually join into federations to conduct business. For the consumer marketplace, when you go home, where will you get your middleware services from? Your collaborative support? Well, there's a lot of companies who want to provide that service, and unfortunately, they're fighting over the marketplace before they build the marketplace. Always awkward. But I think they're coming together to actually create the marketplace. Some of the people who want to provide those services includes Microsoft with their .NET service. Interestingly, most of you decided you didn't want to give your personal information to Bill Gates. And so they're rethinking about how to do this. It is also the case that your ISP wants to be your identity service provider. And AOL would love to hand out, to help you manage your credentials in life. Telecoms want to. Nokia wants your cell phone to be your personal identification device. Consumer products want to do that. United Airlines, if they stay in business, wants to be my identity service provider. And banks. And I believe at the end of the day that we will often use banks as our identity service providers because we already have trust relationships with them. They have auditors in place. You give a lot of money to a bank and they give you a piece of paper back. Why shouldn't they manage other things about you on your behalf? And again, we have a sense of integrity about banks. Whether that's valid or not will be seen over the years. So federations are happening. 8 large banks have come together to form a federation called Securities Hub that allows research reports to be shared among customers. The Swiss are building a federation that are using the Shibboleth tool. We are doing something similar in the United States. We have an experimental test bed called Club Roadkill. I'm not sure how roadkill translates, but it seems to work. And then what's driving all this is several pieces of software rolling down the road right now, available for downloading right now, that are driving this federated enterprise. And it includes the Liberty Alliance, it includes the federated .NET services, Shibboleth, Pappy from Red Iris. Those are among the technology drivers. So lastly, we think that the federations, especially in this room, will come together into a cluster. Similar interests and share metadata, but we may not have the same trust mechanisms in place. We'll come back and look at this over the years. So I think it's time to bring in Jean Bleu, who is a biologist at the Center for Medical Paramecium, a very important activity, also teaches graduate classes at the university, treats paramecium that are ill at a clinic, and is single and available. My graphic skills are very poor. Meet Jean Bleu. It's what clip art can do and nothing more. So Jean Bleu is in the middle of a morning of research. They begin by checking on their grid computation. They do this by logging on to their local network and their local environment. And then there is a tool in that environment which converts their identity into the identity that they're known on the grids. And so with a single login, they can now look and see how their grid computation is processing. They're going to also work on a collaboration site. I'll show you that in a minute. They'll do some video conferencing with peers. They'll look at some research journals, and they'll referee a paper, a typical morning of a researcher. The tools they'll be using in this morning include signed email. And if you don't know what's happening in email these days, if you thought spam was bad, there is a new capability out there. There are websites that allow you to type a message that you want to go to someone, the name of the person you want to send it to, and the name of the person you want this message to appear to have come from. And then you click send, and this person will receive a message from not the right person, and it may be very much out of character. And in most mail clients, if you looked at the cross-headers the way us middleware geeks will do, you can find this out, but most mail clients won't even display those headers. So we are about to enter a world of a new kind of spam where the messages sure seem to have come from your boss, and they're telling you that your time is done. And we have to get to signed email very quickly. There needs to be middleware-enabled video conferencing. I'll describe that in a second. We need convertible credentials where your local credentials can act in a global mode. We need authenticated and authorized use of resources where those authorizations come from local permissions and also from your virtual organization permissions. We need privacy as required. There may be, as a reader, you have absolute privacy. You can browse these electronic shelves. When you're a referee, it would be good to know that you're a referee, anointed as a referee, but you still want some privacy because the reports from referees should be private. So we need to know you're a member of a particular subclass, but still want to protect your privacy. And then lastly, as an editor, editors you know by name, they know you by name, and so we need all of those functions. So, as Jean Bleu goes to the to the collaborative website at a foreign university, they log in locally, and then they use that local login to demonstrate to the remote site who they are. And that site will say, you are in fact permitted to upload and edit this website, and we'll do that, and we'll leave an audit trail behind. But then we recognize that this collaborative website will be viewed by anonymous users, so you now log out and you log back in as an anonymous user to revisit the website and make sure you can see some content but not all of the content, that you have some capabilities but not all of the capabilities. And then we revisit the website one more time as a graduate student, where the attribute being a graduate student entitles you to some more capabilities but not all of that. And you begin to see how in an attribute-based world, there are various capabilities that are linked less to your identity and more to your roles and authorizations. This is where we are headed. We also want middleware-enabled video, and we're getting very close to this. In middleware-enabled video, I click on somebody's name to initiate a video conference. That's not how we do it today. Today, we type in these long strings of digits, and then another long string of digits, and then perhaps a third. And out of all of that, the user on the other end never gets the right to say, I don't want a conference from this person. If I'm doing video conferencing today with my laptop, I open up a port, and I have no other control. So the next thing I may see on my screen is somebody's face who I do not want to see, or some other part of them that I definitely don't want to see. So we want a knock on the video conference door so that you get to see a message that says, excuse me, but Peter Dietz wants the video conference with you, and Dazi.com asserts that it's really Peter. Do you want to accept the video conference? Most definitely. I want authorization. The environment that Peter lives in may say, oh, it's Peter. We don't give him much bandwidth. I want this to work across multiple environments, 323, SIP, access grids, VRVS, and I want privacy as needed. Now, I have thought long and hard about where do you need privacy in video conferencing. My only candidate right now is virtual confessionals, but I would welcome somebody giving me another example down the road. Jean moves on to an afternoon of teaching and administration, adding research results to a class site, booking travel to Tirrenia 2008. Where is that going to be, Carl? Doing some instant messaging, virtual office hours, evaluating a resume, etc. Let me look at one or two of these in a bit more detail. Again, the tools we'll be using will be signed email, middleware-enabled video conferencing, roles, trying more and more to fit you into roles. If we're going to do roles, we better do exceptions to roles as well. We want privacy-enabled educational services, enterprise-enabled federated peer-to-peer, I'll explain that, local associations, and digital rights management, typical collaborative tools. Let me explain a little bit about a new application that we're working on in what we call federated peer-to-peer. There is some software being developed at Penn State University that allows file sharing, but it's file sharing of the good kind versus of the Napster Nutella kind, in that you begin by authenticating to your enterprise. And your enterprise says, great, I know it's David Chadwick, and he's permitted to do certain things, and everything that this client will do will be registered against David Chadwick, so should some Walt Disney come along and have an issue, we'll be able to find David. So there's authentication of clients to enterprises, and then there's authorization that says David can do some things but not other things, and David can only do these things between the hours of 5 p.m. and 1 a.m., and all those other kinds of capabilities. The same tool is good in that when you authenticate, you upload the indices of the objects you have to share. And it's being used at Penn State today to share art slides among students in an art class. And so that is a very important capability, because those of you who know peer-to-peer applications know that they spend 90% of their time trying to find each other and only 10% of the time actually doing meaningful communication. So having an efficient resource discovery will make peer-to-peer much less noxious. It will only leave the copyright issues out there. Managing the lab assistants. My lab assistants are going to be helping in my grid computations. I would like to be able to drop into the enterprise directory or into the grid directory in my enterprise that these new students have these capabilities because they are my students. I want to have an automation so that when I get new students, they are automatically added to my permission list. I want to sign transactions that say these students are available. And then, most tricky, I want them to be able to look at certain parts of my calendar. They are my students, but not other parts of my calendar. And I want to have this capability perhaps between realms, so that my colleagues can look at when I'm available and try to find a time for video conferencing. Roles, inter-realm roles, calendaring. Finally, Jean moves on to an evening of life. It's a short evening. Books a restaurant, votes in local surveys, and is, again, single and available. Let us look at some of those tools that they will use. They will use signed email, chat sessions, attribute management services, and HIP routers. I'll explain HIP routers in a second. I'll do it right now. So, since Jean is single and available, Jean would like to be in chat rooms, privacy protections, but at the same time would like to know that everybody who's in that chat room is authenticated, even if they don't know their identities right now. And then we'll talk about how you find identities. But before that, Jean moves over and wants to vote in a local survey, only available to singles, and only one vote per person. And so the way this works is Jean votes in this survey anonymously. The survey mechanism drops back into the identity service provider a token that says Jean has voted on this survey, cannot vote again. And then if Jean tries to vote again, that attribute is pulled back from the directory automatically, and Jean only gets one vote. Finally, progressive disclosure services and that HIP router. One of the interesting areas we're looking at is called automated trust negotiation. I walk into a plaza and I want to find somebody who is also perhaps single and available, and I wear my little HIP router from Siena, and this HIP router works on infrared, and so it starts to exchange information with the other HIP routers, and it exchanges very little information at first because you don't want to reveal too much. But you find somebody who has an attribute much like your attribute, and so you're willing to reveal another attribute, and if they come back with another attribute, you reveal yet a third, and then you know where your next hop is, as it were. I think the metaphor went too far. So, what are the key concepts in this collaborative world? Role-based access controls. It is the only way to scale authorization. We need several different layers to scale this technology. We talk about federations, we talk about enterprises and virtual organizations. We need to create solid bases for all of those. We need privacy. I would point out that privacy means different things. In the US, for some strange reason, we trust companies, but we don't trust our government. And so privacy often means privacy from government viewing. Whereas in Europe, again for strange reasons, you seem to trust your governments and you're not your corporations. And so we need to understand what privacy means in this space. I would point out that we have lost absolute privacy. It will not be the case that no one knows your behavior. Your identity service provider will know your behavior, but it will conceal that from other people until the subpoena comes in? Presence. We have so many communication devices, so many collaboration devices. Which one are we on right now? How do we indicate that? How do we say, I don't want to get a video call on my PDA because it doesn't have the right hardware? So we need to work the space of presence. Diagnostics. We tend not to worry about diagnostics till after we deploy something, if at all. Well, we're going to get some very strange error messages in the future. There will be Roland Hedberg will go to a site and we'll get a message back that says, excuse me, Mr. Dietz, you cannot use this site. And Roland's going, but I'm not Peter, I'm Roland. How do we begin to diagnose that? In what table was there a wrong entry mapping one identity to another? And lastly, trust. All of our services are built on trust models. We have to solve that. So what could go wrong? How could we fail? A single vendor wins. We do not have a marketplace. We have a monopoly. I do not think that's going to happen. A marketplace does not get established. Remember VHS and beta? Sometimes the marketplace mechanisms do not work. Again, we saw people fighting over mechanisms in the past, but we're starting to see now an alignment in this service area. In particular, we're looking at our shibboleth work and the Liberty work, and we're starting to use a word, schliberty, to indicate a possible convergence around a marketplace. It may well be that users just don't care. And 95% of the users will say, oh, this is painful. We used to joke that a sign of success would be that you would go to a website and before you got there, 400 pop-up windows would say, are you sure? Are you really sure? That's not what the marketplace wants. So we need to make sure the default settings are such that those windows don't happen. It may be that this idea of federations that we all talk about will prove costly or difficult. We have tried to keep the lawyers out for as long as possible, but they are knocking on the door. We are going to have multiple federations. How will they work together? And that the international issues may prove intractable. That safe harbor and other kinds of laws may prove very difficult to actually implement in technology. So we could easily fail and things could go wrong. We could succeed and things will go wrong too. We may have an erosion of privacy. This may prove so difficult to handle that users go, tell the world everything. Or we may have put all of our privacy coupons in a way with our identity service provider, and they get cracked. We have put all of our eggs in one basket. Or lastly, there is a saying that Bob Morgan, who helps many of us, says about what is the unified field theory of privacy, which is, my privacy is very important to me. Your privacy is not particularly important to me. I will sell my privacy for an appropriately defined rubber squeeze toy. And it's true. We give away our privacy to our supermarkets day in and day out for a 5-cent discount. So that may be the way that we go, that for the right trinket, we will give away our privacy. We may spend all of our time managing collaboration, handling all the different modalities that we have to communicate with, all the complexity that we have, and then the global issues of time zones alone will prove very problematic to try to schedule collaborations. We may have identity tampering. Identity theft is good in that you know your identity has been stolen. Identity tampering is where they change a few of your attributes, but not all of them. And suddenly you're subscribed to a list because somebody has put an attribute inside your identity service provider that says you have a preference for toads. And what do we do in that environment? And lastly, the effects on quality of life. I believe everything we have done has had unintended consequences. I want to close with that. I want to talk about two issues, both apply to turtles. The first is the Bertrand Russell turtle. Perhaps you know the story that at the turn of the 20th century, Bertrand Russell was giving a talk, and a woman stood up in the audience and said, "That's all very good, Dr. Russell, but we really know that the world is carried on the back of a turtle. And Dr. Russell said, so what is the turtle walking on? And she said, on the back of another turtle. And he said, but what? And she said, stop it right there. We know that it's turtles all the way down. So, in fact, will the layers get to be too much? Will there be too much complexity here? Will this be manageable? The other turtle story is by Edward Oppenheimer. Edward Oppenheimer was walking the grounds of the Advanced Institute at Princeton shortly after the development of the atomic bomb. He was walking with a friend. They found a turtle crossing the path. Oppenheimer picked up the turtle, put it in his pocket to take home to his daughter, walked 75 yards down the path, stopped, turned around, went back and put the turtle exactly where he found it, and said to his friend, I think I have done enough damage to the world for one man's lifetime. We are all in the process of doing damage. We must do it carefully. We should do it because if other people do it, they will do more damage. But we have to be careful. Thank you.
Thank you, Ken.